Hey guys, so we're going to be doing some very difficult exam questions today. I've seen there's a few people in the chat already. Someone's asking about whether it's further maths. No, we're just focusing on normal maths at the minute. But I've picked some questions. I mean, obviously I'm not going to pick the hardest ones possible. Most of those have already been covered on my channel in the my top hardest questions that have ever been asked before. Maybe I'll do an update on that after a few years more of questions have come. But for now, I've picked these questions from different parts of the international papers. So I'm going to start off with one in just a moment on something that is a bit more, I don't know, like a slightly gentler way into this kind of thing. We're going to be doing one on some proof by contradiction as the first part, but then afterwards we will be doing some pretty tough topics. And then maybe if you like this kind of live stream, maybe I'll do some more live streams as we kind of progress from all of this. And I'm seeing people in the chat. I've got my other screen over here so I can see people sort of already saying hello in the chat. I'd love it if I could find out where you're from. Where are you sort of staying? Not where are you staying, where do you live in the UK? Obviously, you guys know that I'm in Manchester. I'd love to know where else people are as well. So, yeah, what else have I been up to today? So it's been really nice weather. I met a friend in the afternoon, and then I've just come back to do the live streaming. But before I've been doing that, I've been doing so much preparation for these Easter classes that I've got. So I've got classes on pure mechanics, statistics, core pure, further mechanics, further stats, further pure one. I've got loads and loads of stuff like that prepared. So I've basically just been doing a ton of preparation for that. And those sessions are going to be really good. If you're interested in any of that, it's all linked in the description. Okay, here we've got people from Bournemouth, Milton Keynes, East London. Obviously, I'm going to be a big fan of East London. We've got someone from Mumbai. That's amazing. Reading, Lincoln, Leicestershire, Sheffield. Amazing. Okay. No, so I've got someone from London. No, this is just going to be maths for now, but I will be doing a further maths one as well. And Jason, yes, I think I probably am considering making a predicted paper. I don't know if it will be like a predicted paper, but it will be like a best kind of guess. Definitely. And we've got someone from Tower Hamlets. Best place in London. That's where I worked for so long. That's where I worked and lived. I absolutely love that place. So yeah, this is going to be available after the live. I've got the chat over here, so I will do my best to kind of watch what is going on. In fact, if I just kind of switch some of my windows around here, I can see the chat even more clearly. We've got someone from Sunderland as well. Okay, so I've got this new kind of setup where hopefully we're going to be able to see the questions directly on the screen like this. So I've been investing in some new technology, and this new technology that we've got is so that I can use my iPad at the same time that we've got here. So we've got these 5 different questions that we're going to be doing. They're all on pure at the moment. Someone's asked if I'm going to be doing mechanics and statistics anytime soon. I will be doing one of these on mechanics and statistics soon, but I wanted to start off just doing pure just because it kind of feels like the most kind of classic kind of thing that we're going to be doing, okay? And I do go over all of the mechanics and stats and pure stuff in my Easter sessions. And if you do receive a bursary from school or anything, if you get in contact with me, I give you a very big discount to those sessions. So you can always contact me with evidence of that as well, okay? So let's have a look at this first question that we've got here. It says we're going to use proof by contradiction to prove that the square root of 7 is irrational. Then afterwards it says you may assume that if k is an integer and k squared is a multiple of 7, then k is a multiple of 7. Usually, what do we normally do when it's a proof by contradiction? Not what do we normally do, but we don't normally do it with the square root of 7. What's the most common one that we've probably seen this with before? Where might we have seen one of these? It's not typically with root 7, it's with root 2. So it's going to follow this same kind of logic that we've got here. And what we do to start this off is we will assume, you don't have to say for a contradiction, but I always like to say assume for contradiction that the square root of 7 is equal to a over b. And crucially, we need to say where a and b are integers with no common factor. Now, I'm going to explain in a moment why they can't have a common factor. There's a particular reason why they can't have a common factor. And so with these kind of proof questions, we all just need to kind of get started with doing something. So if I take this statement that we've got here, the root 7 equals a over b, feels like there's really only one thing I can do, which is to square both sides. So if I square the left-hand side, I get 7. And if I square the right-hand side, I get a squared over b squared. So kind of focusing on this a bit more, if I multiply up, I get that 7b squared is equal to a squared. And this tells me something. This tells me that a squared is a multiple of 7. And the reason that I know a squared is a multiple of 7 is because it's the same as b squared that has been multiplied by 7. And then this is where the statement kind of comes in useful here. It says if k is an integer and k squared is a multiple of 7, then k is a multiple of 7. So here we've said that a squared is a multiple of 7. Hence, we can say that a is also a multiple of 7. Now, if a is a multiple of 7, we could say that a is equal to 7k, where k is an integer. And what we can do with this fact is we can take it from a being equal to 7k, and we can just substitute it back into this statement, or the original statement. It's not really going to make much of a difference. So we now get that 7b squared is equal to a all squared. So 7b squared is equal to 49k squared. Divide both sides by 7 and we get b squared is equal to 7k squared, like this. Now what does this tell me about b squared? What does this tell me about b squared? And I'm going to keep an eye on this in the chat. I think I can see people coming through in the chat as well. So what does this mean about b squared? Good, Jason and Chloe and RNSS alt. So this means that b squared is a multiple of 7. Hence b is also a multiple of 7. So both a and b are multiples of 7. So they have a common factor. So they have a common factor, which is a contradiction. This kind of feels more like an English paper, doesn't it? The amount of writing that we've got to do here. Because do you remember at the beginning we said this? We said that they have no common factors. And so we've actually got a contradiction to that because they do have a common factor. So then we need to finish off and actually do a conclusion statement, which is to say, hence, the square root of 7 is irrational. Now, I'm going to try and explain to you something that maybe isn't explained very well before. But what I'm going to say is why they can't have any common factors. Because you're just like, okay, well, what's the issue of them having common factors if they're both a multiple of 7? Well, the difficulty is, if they were both a multiple of 7, then we could cancel this fraction down. Instead of it being a over b, we could cancel it down and divide the top and bottom by 7 to come up with some new fraction, which would be c over d, right? But then we could do the exact same algebra again and show that c and d would both have a multiple, would both be a multiple of 7, and they have a common factor. So c and d, you could also cancel down by dividing by 7. And then you could do that with e and f, you could do that with g and h, and you could just do that forever and ever and ever without stopping. And we know that this is just not the way that fractions work. You cannot have a fraction that you can continually simplify down and down and down. So that is why they have to have no common factors. Otherwise, this proof would just go on for infinity, which doesn't make any sense. So it's a lot of writing for just 4 marks, but it's definitely one that you could be prepared for. It's the same with the square root of 2, and you can do it with the cube root of 2. It just has similar kinds of properties with this as well, okay? You'll notice that I've taken this from the international papers from Pure 4. If you want to find some more proof by contradiction questions, you can find lots of them in the international papers. There's loads and loads of those questions that we have there. So now I think we're getting on to some of the more kind of serious stuff in these questions that we've got. We have now got to have a look at a parametric one, and I've deliberately picked this one because it's parametric and it's trigonometry. So if you thought the first question was fine, we've got slightly heavier kind of stuff coming up in the rest of these questions. So it says a curve has parametric equations x equals sine squared t and y equals 2 tan t, and t is between 0 and pi over 2. The point P with parameter t equals pi over 4 lies on C. So we've got this part here, and I'm actually just going to kind of jot down on the diagram that at that particular point, t is equal to pi over 4. And then it says that the line L is the normal to C at P as shown in figure 3. So we've got this part here, and I think that the fact that there's a normal is going to be incredibly important. I don't know, does anybody ever do that in an exam question where you think you know exactly what you're doing and then suddenly you forgot that it's a normal and you've done the whole thing as a tangent? So I always like to kind of point out the things that are very easy for us to forget. So we're going to start off, I started doing this question earlier to see if I'm going to get it nice and prepared. What we're going to do for this one is we're going to start off by finding the equation of that line. So we need to find out what dy by dx is. Does anybody remember how we find out what dy by dx is when something is in parametric form like this? This is A-level maths. Yeah, this is not AS. This is definitely A-level. So I'm just going to see if there's anyone in the chat saying how we do this. Yeah, I've got lots of people coming up with this. So we need to find out what dy dt, dx dt, lots and lots of different things. They're definitely differentiating them and then thinking about combining them together. So I'm going to begin by differentiating the x part. You'll notice for the x, even though it's written as sine squared t, I tend to write it like this. I think it helps me remember how to differentiate it better. So I'm going to differentiate this. So I'm going to pull the power down. I'm going to reduce the power by 1, and then I'm going to multiply by the derivative of sine t, which is cos t. And then I'm going to differentiate tan t. Tan t is going to differentiate to sec squared t like this. And then we have that dy by dx, loads of people have said this in the chat already, it's going to be dy by dt divided by dx by dt. So dy dt is sec squared t, and we're dividing that by 2 sine t cos t like this, okay? And we just actually are trying to find out what the equation of the normal is. So I don't really think there's anything in particular that I should do any simplifying. Maybe it would be quicker to do it. I'm not really sure whether it's worth doing it or not. But we are trying to find the normal at this point here where t is equal to pi over 4. So because t is equal to pi over 4, I'm going to find out what dy by dx is. Now, personally, when I do this, I think there's an awful lot of typing into the calculator with putting pi over 4 into this part. So I usually like to do like a little bit at a time with this, and I find that can make things a bit easier. Now, I know what some of these are off the top of my head, and I hope that you do. Does anybody know what sine pi over 4 or cos pi over 4 is equal to? So we've got y equals 2 tan t. Oh, why is 2 tan t in the question? Whoops, okay, let me quickly fix that. So I've seen that people have fixed this. This is 2 tan t, another mistake that can be made, which means there's got to be a 2 here, a 2 here, and a 2 here. Apologies, I just copied the question down wrong, so those two cancel. But sine pi over 4 is either root 2 over 2. I personally just remember it as 1 over root 2, but if you want to get it from the calculator, it's the same as root 2 over 2. That's what cos pi over 4 is equal to as well, 1 over root 2. And I'm also going to say what sec of pi over 4 is. Sec of pi over 4, well, that's going to be the cos, 1 over the cos of pi over 4. So it is just going to be the reciprocal of this one, which is just root 2. Now, you're probably thinking, why am I doing all this? My advice to do this is it should make the substitution stage a little bit easier. So I'm now going to have sec squared t, which is going to be root 2 all squared, obviously going to be a 2. And I have sine t multiplied by cos t, so it's going to be a 1 over root 2 times by a 1 over root 2. 1 over root 2 times by 1 over root 2. So the numerator is 2, and the denominator is a half. So when I do 2 divided by a half, I get 4. Okay, I'm trying to do this without a calculator if I can, because usually that makes things a little bit easier for me. And we're going to be doing the equation of the normal. Good job I highlighted this, because I'm now going to have to take the negative reciprocal. Let's add in an extra page. So the gradient of the normal is going to be minus 1/4. Now, what else do I need to be able to find the equation of the line? I think there's something else that's missing here. The coordinates. Fantastic. So I'm going to use the facts that I've got up here and here. I'm going to find out what the x-coordinate and the y-coordinate is. So the x-coordinate is going to be sine t all squared. Well, that's going to be, that's the sine of pi over 4 squared. Well, we've already worked out the sine of pi over 4. It was 1 over root 2. And when you square that, you just get 1 over 2. And the y-coordinate is 2 tan of pi over 4. I know that the tan of pi over 4 is 1. So it's just 2 times 1, which is 2. So I'm going to use my equation, which is my y minus y1 equals m brackets x minus x1. So that is y minus the y coordinate. Remember, we're using our x, y coordinate over here, equals m brackets x minus the x coordinate. So we basically have the equation of the normal. We just need to make sure that it looks like their one that they have here. So the y part has been times by 8. I'll start off just by timesing it by 4 to get rid of this part. So when I times by 4, I get 4y minus 8 equals, there'd then be a minus x minus a half. So 4y minus 8 is equal to minus x plus a half. Okay, now I can see why there was an 8 with the y, because I want to get rid of this a half here, and I'm going to get rid of that by timesing everything by 2. So 8y minus 16 equals minus 2x plus 1. And then I think that's what they've got, right? They have 8y plus 2x equals 17. 8y, I'll plus the 2x, I'll put the 16 onto the other side, and I get the 17 like this. We've done a bit of parametric calculus with this part. We're now going to have a look at part B. It says that the region S, shown shaded in figure 3, is bounded by the curve L and the x-axis. We want to find the exact area of this. Now, when I look at this, I see this kind of area in two ways. Can anybody think like what kind of shapes that I'm really talking about here, that I'm really looking for? Like how I might try and split that S area up that I've got, how I might do that. So we've got Brandon, R. Brown, Jason, Arian, we've got triangles and stuff, and Nando Boy with a right angled triangle. But also we've got an area underneath the curve. I wouldn't necessarily say a trapezium, because I think that this part here is a curved line. It's kind of not that easy to see. So this is actually a curved line that we've got here. So I am going to split it as a triangle on this one side, and then I've got the curved part. So the curved part, I need to find the area under here. Now, we know for this part that t is equal to pi over 4, but I just need to check what t is equal to here. Now, you might just guess that it's 0, but it could have been pi over 2 as well. So we just double check at the origin. Well, if t was 0, you have the sine of 0, great, that's 0, and you have the tan of 0, great, that's 0. So this part is where t is equal to 0, but sometimes with parametric, it can actually do it kind of the other way around. We could have had 0 over here and pi over 2 down here. It kind of depends on the context of the question. So for the parametric part, we're going to be integrating between the limits of 0 and pi over 4, and we'll come back to the triangle in a second. So for part B, we're going to have the parametric part and then the triangle. I'm going to say to myself, we'll do the parametric curve area plus the triangle area. Does anybody ever do these questions or something similar like this, and they forget to kind of like add on the triangle area at the end? So I always like trying to kind of give myself some like reminders of not forgetting about these things. Now for parametric, we normally integrate y with respect to x, but because y is in terms of t, we have to do this instead. And if you haven't learned this yet, you're still going to be able to follow the rest of the question. We have to integrate y, multiply it by dx dt, and then we can integrate it with respect to t. And these limits need to be the t limits from the question, which are between 0 and pi over 4. So I'm going to go down here to a 0 and then to a pi over 4. And I can just start filling in what each of these separate parts are. So y was 2 tan t. Y was 2 tan t, right? And dx dt is 2 sine t cos t. So that's going to get multiplied by 2 sine t cos t dt. And then you can either do this sort of working it out in here, or you could do it somewhere else on the side of your page. I would probably think to myself, okay, well, I have a 2 tan t. Tan t is sine t over cos t. And that's getting multiplied by 2 sine t cos t like this. And so the coses actually cancel, and what we get left with is we're integrating between 0 and pi over 4 sine squared t dt. Now this is probably the hardest part of this question. If you do further maths, you probably know about what we're doing here. You probably have a good idea about how to integrate this, but I would love to see in the chat, what do we do when we're trying to integrate sine squared t? What do we integrate when we're trying to do sine squared t? People normally think, oh cool, it's going to be sine cubed t, but it's not. Wow, I'm seeing some good answers already. So we've got Billy English saying, use the cos 2x identity. I think Ramo Plays has come straight in with what we're looking for. We use the rearranged double angle formula that we've got. Someone said that the limits are wrong. I'm not sure that the limits are wrong. I think the limits are between 0 and pi over 4 for this part that we've got here. But we're going to use the rearranged double angle formula for cosine. So if you don't know what I'm talking about here, I will go a little bit slower. We will remind ourselves that cos 2t is 1 minus 2 sine squared t. So when I shuffle this around, 2 sine squared t is 1 minus cos 2t. And so sine squared t, when I divide everything by 2, is a half minus a half cos 2t. If you ever see sine squared by itself like this is how we're going to integrate it. So between 0 and pi over 4, I'll do the 4 multiplied by the half minus a half cos 2t dt. Definitely going to add in another blank page here. And as we continue with this, we have 2 minus 2 cos 2t dt. So we can finally do the integration for this part. 2 is going to integrate to 2t. I know this is going to be a sine 2t because sine differentiates to cos. And actually, I don't think there's anything else that's needed there because this 2 would get brought down when we differentiate it. Sine differentiates to cos, and we'd have that extra 2 that comes with this one that we have here, okay? I'm just seeing if anyone thinks that I've got any of the incorrect limits or anything. We could integrate the line equation if we wanted to, but I don't think we're going to want to integrate the line equation for this one because a triangle is just going to be much more simple. So what I'm going to do is just substitute in the pi over 4 into this. So 2 times pi over 4. That's pi over 2. And then I'm going to be doing minus sine of pi over 2, minus the sine of pi over 2. And then I'm going to be subtracting a 0 and a 0, because when you put 0 into both of these places, you get 0. Now, sine of pi over 2 is 1. So we're going to have pi over 2 subtract 1 for this part, okay? We're now going to have to figure out the area of the triangle so that we don't forget about the triangle area. So the triangle area. Well, we did work some things out about p earlier. I think we found out that the coordinate of p was a half and 2. So I now know that p's coordinate is a half and 2, meaning that this part of the triangle is 2. I now want to find out what the base of the triangle is. Okay, I want to find out what the base of the triangle is. So I'm going to do this on this part of the page. I'm going to say I need to find out where it crosses the x-axis. It crosses the x-axis when y is equal to 0. When y is equal to 0, 2x is equal to 17. I don't even have my calculator with me. Not that I need a calculator for that really, do I? But I will probably need it later on. And 17 divided by 2, well, that's going to be 8.5. So this is 8.5. We've just said that the x-coordinate over here is 0.5, which means that the base of the triangle is the gap between 8.5 and 0.5, which is 8. So we have the base of the triangle is 8, the height of the triangle is 2. So the area is the base times the height divided by 2. So the area is just 8, meaning that the S area is equal to the parametric part plus the triangle part, which is pi over 2 plus 7 that we have for this question. Pretty difficult question, right? Really difficult question. How do you think people would feel? How would you feel if you saw that question in the exam at this stage with your revision? Would you feel confident? Would you feel a bit intimidated by this question? Was this maybe a bit too hard? What do you think? Because I think this is a really challenging question. I'm going to have a quick look at some of the chat that's coming up as well. So, okay, people saying it's beautiful, calm, feeling happy, freak out and pray. I mean, like, listen, if you're motivated enough to be in a live stream on, the 19th of March in the evening, then you're probably a pretty good student, right? So that sounds good. I tell you what, a lot of people are going to find this very, very challenging. And I think that last part of the triangle was quite tricky as well. Now, if you do like the way that these sessions run, you like the way that I'm explaining things using the iPad, this is pretty similar to how the ones that I do on Zoom are. So if you're interested, do come along to those sessions online. I think you'd find them really helpful. So each year people have found them helpful anyway. And there's that correct answer of that pi over 2 plus 7 that we've got there. Okay, so Is this one hard or not? I don't know. We'll see what we think of this one in a moment. It doesn't look that hard, but it does look like there's a lot of writing. I picked this question because I particularly liked how the last couple of questions, well, particularly the last question, like brought in some other parts of some maths as well. So I'll tell you what, let's just read through it and see how things are going. So we've got the volume of a spherical balloon with radius r is given by this formula. So people often say, oh, you know, what formulas do we need to remember? Well, usually they will give you it, but this is the volume of a sphere. And then for the first part of the question, nice and easy, it says find dv by dr, giving your answer in its simplest form. So I'll tell you what I'll do is I will write down that v is 4/3 pi r cubed. So we're just going to differentiate, right? We're just going to say that dv by dr is this thing. So I will pull the power down. So 4/3 times by 3 is just 4. And I will reduce the power by 1. Obviously, pi is just a constant, so it just stays there. There's no reason for it to be kind of messed with at all, okay? Easy for 1 mark. It then says, at time t seconds, the volume of the balloon is increasing according to this differential equation that we've got here. And they tell us that v equals 0 when t equals 0. We're going to try and solve this differential equation to show that v equals 300t over 2t plus 3, and then we're going to do something to do with the upper limit to the volume of the balloon. Okay, so differential equations. When we do differential equations like this, when I have dv by dt equals 900 over 2t plus 3 squared, normally we might have like a mixture of different things, or I might have that this thing over here is to do with v, so I would have to put it over on this side with v. But at this stage, there's everything to do with t is on the right-hand side of the equation. So all I really need to do is take this dt and just put it on this side, and then I'm going to integrate on both sides. Normally we need to do quite a lot of shuffling around, but this question, we don't need to do much shuffling around. So I'm going to put, the dv is going to stay solo, and on the right-hand side, I'm going to have my 900 over 2t plus 3 squared, and I'll put the dt there. Now it's looking like that. I'm going to put integration signs on both sides. Okay, they look a bit like S's. I'll tell you what, I'm going to make them look a little bit more like integration signs. Now, there isn't actually anything written here. So what do you think I should imagine that is actually written here? What could I imagine that's actually being written? Yeah, it's just a 1. Okay, now you don't have to write it, but there is a 1 here. And when we integrate 1 with respect to v, we just get v. And I probably would like to rewrite this because what's usually the thing that people want to integrate this to, but that's completely wrong? What's usually what you see people trying to integrate that to? And maybe that's going to confuse you. You could bring the 900 to the left, by the way, but you don't need to bring the 900 to the left. It's perfectly fine to leave it where it is right now. Yeah, there you go. We've got Serraro, Todd, Calton. People love to do ln. This is not going to be ln because of this power of 2. So I personally prefer to rewrite it like this. And then I can just say to myself, okay, cool. I'm just going to have to do the reverse chain rule here. So I'm going to increase this whole power by 1 so that it goes to 2t plus 3 to the power of minus 1. I have to counteract now this new power by putting a minus outside the front. And there's something else that needs to change. It can't be a 900 there. What should it be instead of the 900? It should not be a 900. It's what should be there instead? And I'll say why. Yeah, it needs to be a 450 because of this extra 2 that we get from differentiating it. So it needs to have a 450. I'm going to show you why this works, okay? Very, very, very quickly. If I differentiate this whole thing, I would have minus 450. I will pull the power down. I will reduce the power by 1, and I will also multiply by the derivative of that thing I've just underlined, which is a 2. So I have the negatives cancelling. I get 450 times 1 times 2. That's 900. And I have the 2t plus 3 to the minus 2. That is exactly the thing that I was wanting it to look like here. Okay, so I know that I've done this correct, so I can get rid of all of that. And of course, I've integrated, so I need a constant. You might have said, why didn't I do the constant on this side? You only need the constant on one of these sides that we've got here, okay? So we're now going to go back to the question and use the fact that it's given us that when v is equal to 0, t is equal to 0, and that should give us enough information to find out what c is equal to. It's basically talking about a balloon filling up, right? So it's saying when it started off, there was no volume in the balloon. Nobody had started like putting any air into it. So when v is 0, t is 0. So 0 equals minus 450 times by, what's that, 3 to the power of minus 1 plus c. Well, I'll put this 450, 3 to the power of minus 1 is this. And so 450 divided by 3, obviously divided by 3 was because it was 3 to the power of minus 1. That is just that c is equal to 150. So as we continue with this question, we are now going to say that v equals, this is me taking this statement here, I'm going to continue with it. That's minus 450, 2t plus 3 to the power of minus 1 plus 150. So I think we've got it. I think we just need to keep going with this. And I think we need to make sure that it ends up looking like this thing, 300t over 2t plus 3. So let's keep working. So that's minus 450 over 2t plus 3 plus 150. Well, they need to have a common denominator. So to get a common denominator, this one is going to need to be multiplied by 2t plus 3 on the top and bottom. So the numerator becomes minus 450. I'm then going to expand these brackets. 150 times 2t is 300t, and 3 times 150 is 450, all divided by 2t plus 3. So the 450s cancel, and we do get left with the 300t over 2t plus 3 that we've got here, okay? So that was 4 out of these 5 marks, because there is a second part that says find the upper limit to the volume of the balloon. What is the upper limit to the volume of the balloon? So what was that? B part 1. Now we'll do B part 2. And there's loads of different ways of doing this, but because the volume is equal to 300t over 2t plus 3, I would just say the easiest one is just to put a really big value of t into the calculator. So if I put in, like, I don't know, that t is like 10,000 and just do that calculation, it should just give us what the upper limit is going to be. You might need to do a tiny little bit of rounding. So I'll do 300 times by 10,000 divided by 2 times 10,000 plus 3. And I get the volume is 149.9775. Okay, well, that's kind of obvious, really. It's now saying that the upper limit of the balloon is going to be 150 centimeters cubed. Now, mathematically, the reason that's working is because when you make t a really, really big number here and here, this plus 3 becomes completely insignificant, because if you're adding 3 on to like 10 million, this doesn't really change it. So you end up with basically 300t divided by 2t, 300t divided by 2t, the t's cancel, you just have 300 over 2, which is 150. Okay. We've got quite a lot of questions to get through. So it says here, for part C, find the radius of the balloon at t equals 3, giving your answer in centimeters to 3 significant figures. Okay, well, I think we're probably going to have to use what we just had here. So if I find out, I want to find the radius of the balloon when t equals 3. Okay, well, that's not a problem, because when t equals 3, I can find out the volume. And then I can use the volume to find out the radius. So it's kind of like a chain of different formulae that we've got going on here. So for part C, we're going to say that t is equal to 3. We're going to find v. Then we will find r. So the volume is going to be 300 multiplied by 3 divided by 2 times 3 plus 3. So what's that? 900 divided by 9, which is 100. We've also found out at the very beginning of the question that volume is equal to 4/3 pi r cubed. So this is the volume, and that's going to be equal to 4/3 pi r cubed. So just a little bit of solving. I'll multiply by 3 and divide by 4. That's pi r cubed. I guess I should divide by 4 pi. That's r cubed. So I'm just going to figure out what r is by doing the cube root of 300 over 4 pi. So on my calculator, the cube root of 300 over 4 pi, and I get that the radius is 2.88 centimeters to 3 significant figures. I think this is all going good so far. Oh yeah, it did say 3 significant figures as well. I'm just going to see if there's anything I've missed in the chat as well. Yeah, someone saying is this year 2, like definitely this is that. And Slay Queen, Work It Girl, I mean, I guess. Just so mad things people say. Okay, last part of the question. This is where I think it's an interesting question. This is why I selected this one. It then says, find the rate of increase of the radius of the balloon at t equals 3, giving your answer to two significant figures. Show your working and state the units of your answer. Now, when I see this phrase here, what does that make me think of? What does that make me think of? Definitely differentiation. I like time. I like dt. I like, in fact, my favorite answer of those is Jason with it makes me think of something dt. Okay. So I'm trying to find the rate of increase of the radius. In fact, if I was to highlight all of that in green, this is dr dt. This is how this thing is changing. So this topic of finding dr by dt, this is a different topic as well. And yes, Ahmed, that's true. So what is this topic? Yeah, someone said it actually. It's like the chain rule. It's like connected rates of change. So I say we do this. We're going to write it as a dr and a dt. They're being multiplied. And then we just fill in these gaps with the other variable. Now, the only other variable in this question is dv. So the only other variable is dv. dv dt, I think we've got. We're just going to have a look at the question again. Yep, we have dv dt over here, okay? dv dt is 900 over 2t plus 3 squared. So on the next line, this is a 900 over 2t plus 3 squared. Now, dr dv, there was a reason they asked us to do this in the beginning part of the question. We found out dv dr, which was 4 pi r squared. So we're going to flip that over, and we're going to get now dr by dv is 1 over 4 pi r squared. We're trying to kind of build up this whole pattern. So we get 1 over 4 pi r squared. And we're going to try and find out what dr dt is when t is equal to 3. Well, that's great. I can substitute that in there. But I need the radius when t is 3. Well, when t is 3, the radius is 2.88. So I can just substitute that t is 3. And the radius is 2.88. Now, I probably do have it stored in my calculator a bit earlier on, but we're just going to type straight in 1 over 4 pi times by 2.88 squared multiplied by 900 over 2t plus 3 squared. I actually think we probably worked that out earlier on. 2t, yeah, I think we did work it out here. No, we didn't. We didn't because it's got the squared sign in it. So this is an awful lot of typing on my calculator, where 2 is 2 times 3 plus 3. So it is going to be 900 for the numerator, and then 4 pi times by 2.88 squared, times it by 2 times 3 plus 3 all squared, and I get 0.1066. They want it to two significant figures, that's 0.11. We then look at this thing to get the units. Well, the radius is measured in centimeters, dt is measured in seconds. So it is centimeters per second, which usually we write as centimeters s to the minus 1. So what did we think? What did we think of that question? We do have the answers correct for this. You can see we've got this answer and this answer, but I'd love to know what you guys thought of this pretty tricky one that we've got. I know what people thought of this one. How do you get better at these questions? I'm just practicing them, just trying loads more of these ones that we have here. Do I have to do the minus one? No, you don't have to do the minus one. If you wanted to, you could write it as centimeters per second, and that would be correct as well. Yeah, so the last part, the reason I knew what to do for that part, Saoirse, was because I thought it was really weird at the beginning of the question that they asked us about this thing. I thought it was really, really weird that they asked us about this. And I knew at some point I was probably going to have to do a chain of, what do you call it, like a chain of these kinds of things. I'll answer some of these other questions at the end as well, okay? Because I'm going to try and make sure this was a lot, this question. This was only, what was this, 5, 6, 7, 8, 9, 12 marks for this question. We've still got 2 more questions to go. So we're going to now try this one here. I'm going to just give you a chance to look at it so I can have a sip of my water. And I want you to tell me to see if you can identify what topic you think this is before we kind of dive in with this question. So can you identify what this topic is? Good, it's an implicit differentiation question. Okay, so this maybe shouldn't take as long as some of the previous ones that we've got, okay? By the way, I'll make these slides available afterwards. I'll put them in the description of the video, so all of my annotations and the mark schemes and stuff will be available. So we're just going to find out what dy by dx is in terms of x and y. So we have y squared equals 2x squared plus 15x plus 10y. Now, you know how to do implicit differentiation. You kind of differentiate as you would expect, and then just add in the extra dy by dx. So y squared we would expect to go to 2y, but you also need to multiply by dy by dx. 2x squared, I'll pull the power down and reduce the power by 1. 15x just goes to 15. 10y just goes to 10. And the dy by dx for that part that we've got there, okay? So does it want it in any particular form? No, it just says find dy by dx. So I'm going to take this 10 dy dx and put it onto the left-hand side. So that's 2 dy by dx minus 10 dy by dx is 4x plus 15. And you can see what's going to happen here, right? I can factorize out so that dy by dx is 2y minus 10, and that's 4x plus 15. Which means that if I just squeeze this in here, I'm never going to fit that in actually. So 4x plus 15, I'll just do it on the next page. What's the problem of not doing it on the next page? I might as well. So dy by dx is 4x plus 15 divided by 2y minus 10. So that's quite a lot. That's not that much work to do for 4 marks, especially when you compare it to, like, I don't know, the 3 marks for this last part of the question. There's an awful lot of thinking that went with this one. And then we get on to a slightly more interesting part. It says the curve is not defined for values of x in the interval PQ as shown in figure 2. Using your answer to part A or otherwise, find the value of P and the value of Q here. And they want to see the method because it says solutions relying entirely on calculator technology are not acceptable. So if you were able to put this on your calculator, we would need to avoid doing that. Now, is there anything you notice about these tangents have been drawn here? What would you say at P and at Q? What would you say is true about those tangents that we've got there? I'm saying it already in the chat. It's a vertical tangent, which means that either dx by dy is equal to 0, or the denominator is equal to 0. So there's a couple of ways to think about it. You're right that you could say, let's flip this over and make it equal 0. I just think to myself, I want these gradients here. I want them to be vertical, and a vertical gradient is undefined. Undefined is also when we divide by 0. So I'm going to make the denominator equal to 0 here. So I'm going to say for part B, at x equals P and x equals Q, the gradient, and you don't have to write this down, this is just me writing it down for the sake of this live stream. The gradient is vertical, hence the denominator is equal to 0, because if you divide by 0, you get that the gradient is undefined, which means a vertical line that we've got here. So this means that 2y is equal to 10, and so y is equal to 5. Now the only option I can do with that is I can take it and substitute it into here, and that's going to give me a nice equation. So I get y squared, that's going to be 5 squared equals 2x squared plus 15x plus 10 times by 5. So we have 25 is 2x squared plus 15x plus 50. So that's 2x squared plus 15x plus 25. And I'm just going to use the graphics calculator to solve this because it doesn't say anything about you must show using algebra or anything like that. Okay, so I'll put this as a polynomial with degree 2, 15 and 25. And we just get that x is equal to minus 2.5 or minus 5. So we do need to make a decision of which one is which, just in case. It's kind of obvious, but x equals p is on the left-hand side, so that would have to be the minus 5, and this would have to be the minus 2.5. So p is minus 5, and q is minus 2.5, okay? So lots quicker than the previous one that we've got here, way quicker. I'm going to quickly go back and just see what's going on with the chat of this part. So yeah, if the numerator is 0, oh yeah, good, someone's doing some good explanations of this kind of part. Cool, so we have still got one more. I think I've got like a nice trigonometry question for us to finish off with. Now there's loads and loads of different ways of approaching this trigonometry question. But I like this one because we've got, first of all, an identity, then we've got an equation, and then we've got integration, all with trigonometry. But the integration part should be kind of easy because it's only a 2-mark question that we've got there. So we're going to dive straight in with part A. And actually, if you find yourself that you've done it in a different method to me, there are different methods, and I'm going to show you one of them in the mark scheme about how this works, okay? So I'm going to begin by looking at this. I'm definitely going to work on the left-hand side of this, and I'm going to try and make it look like this part on the right-hand side. Let's just pull this forward. So I see when I have my cos 2x plus sine 2x, that one's over sine x, and that one is over cos x. My instinct for this, and I'm always wanting to share what my instincts are, because they should give you an idea about how I think. Yes, I should technically be using this this identity symbol. You'll probably just see me doing this. My instinct is to combine this into one single fraction, because clearly I have got 2 separate terms here and here, and I eventually want them to be one single term. So it makes sense for me to try and combine them into one single thing, okay? I'm going to do that by giving them a common denominator. So I get cos 2x. This whole fraction here, it needs to be multiplied by a cos x and a cos x. This whole fraction here, to get a common denominator, needs to be multiplied by a sine x and a sine x. That's what I'm doing. So I get cos 2x, cos x. And then for the next part, I get sine 2x, sine x. And then the common denominator that we have for this question is now my sine x, cos x, like this. Now, there are other approaches to this, but if you take my advice, which is always about thinking about memorizing things, does anybody recognize what that numerator actually looks like? Does anybody recognize what that numerator actually looks like? And this isn't the only way of doing this. I'm going to say that a few times. This is definitely not the only way of doing this. It's just the way that I sort of think about this. Nice suggestion from Arian, but I would be really, really careful. It's almost cos 3x, okay? But I've seen loads of stuff here. I know people are calling it the double angle formula. We mean the addition formula, don't we? We mean it's the cos of the addition formula that we've got here. So quick reminder, we know that cos of a plus or minus b is cos a cos b minus plus sine a sine b. So here, it's exactly the same form as this. So this means that the numerator is actually the same as, well, because there's a plus here, it means it's going to be a minus. It's the cos of 2x minus x over sine x cos x. Cos of 2x minus x, well, that's just cos x, isn't it? That's cos x over sine x cos x. The cos x's cancel, and 1 over sine x is cosec x. Okay, nice, easy way of doing that by recognizing something that we've memorized. There is another way of doing this. The other way you could have done this question is we could have started off and said that cos of 2x is 1 minus 2 sine squared x over sine x. And then we get sine 2x is 2 sine x cos x. But I tell you what, this version gets much more complicated much more quickly. So this is why I would encourage you to try and memorize these formulae and be like, oh, I've seen that somewhere else. I think I can use that, okay? So, part B of the question. Now we always kind of keep going through the flow of this. We now know that anything that looks like this can be replaced with this. Well, look, this thing looks just like that green part, so I can replace it with cosec. The only difference here is that the x has been replaced with a theta, so that means I can replace all of this thing in here with cosec theta. So, part B of the question, we have cosec theta. That's the thing that's been replaced. It was all squared, okay? That's equal to 6 cot theta minus 4. That is equal to 6 cot theta minus 4. So we have cosec squared theta equals 6 cot theta minus 4. Any idea about how we're going to try and use this? Any idea about how we're going to use this? What we're going to do for this kind of equation? I'm just reading some things in the chat. Good, the cot identity. Now I want to know who is definitely going to be a quadratic equation. Who knows the Pythagorean identities off by heart? Who knows all 3 of them off by heart? You're right, someone's also said you could multiply by sine squared x. Perfect suggestion as well if you want to. Good. I like seeing that people know these off by heart. I don't agree with deriving it in an exam. I just agree with memorizing it because it's going to come up probably Wouldn't it be good to just be able to pull that answer straight away? So we know it's 1 plus tan squared is sec squared. The other one is 1 plus cot squared theta is cosec squared theta. If you can memorize this, it puts you in a stronger position. Please take my advice. I've been teaching for a very long time. And actually some teachers disagree with me, but I teach it better. I can get my students to memorize things and be faster in the exam. Remember, exams are a game and you often run out of time when you're playing a game. This is why we need to make sure we have these speedy tricks. So I get 1 plus cot squared theta equals 6 cot theta minus 4. And then I'm going to make this a quadratic. So I'll take everything onto the left-hand side. So that's cot squared theta minus 6 cot theta. And then I have the 1 plus the 4, which is a 5. And it's funny, I say that about other people, about other teachers, because I've often argued with teachers about, I get my students to memorize a lot of things, and a lot of teachers don't agree with me. And I'm very passionate about getting my students to memorize things, because I think it gives you such an edge. So if there's any teachers watching this, maybe you agree with me, maybe you disagree with me, but I'm always trying to get my students to memorize things as well, okay? How many equations? I'll come back to some of these questions afterwards, okay? So this is just a quadratic, so I'm going to put it on my equation solver. That's my 1, my minus 6, and my 5. And this tells me that either cot theta is equal to 5 or cot theta is equal to 1. I'm definitely going to need another page on this one. So we can't do inverse cot on the calculator, so I will take the reciprocal. Tan theta is a fifth, and tan theta, well, the reciprocal of 1 is just 1. So I'll do the inverse tan of 1. I know that one off the top of my head. That's pi over 4. This one I do not know off the top of my head. So let me get myself into radians. So easy to forget to do that. The inverse tan of a fifth. And I get that theta is 0.197. I'm guessing they wanted 3 significant figures. Yeah. And it was just between 0 and pi over 2. So no need to kind of adding around anything else like this. Okay, no need to add on any extra pi's or anything to it. And then for part C of the question, again, it's a classic. Let's try and use the same thing that is in green that we've got here. So I have the green part, which we know we can replace with cosec x, and then we have cot x. So just looks like an integration. Remember, it's only 2 marks, so we're not going to make this too crazy or anything, okay? We've just replaced the green part with cosec x. So that is cosec x. The thing that came afterwards was a cot x. So I'll still include that. And the limits were pi over 6 and pi over 4. Okay. Any ideas of how we integrate this? I'd love to see any suggestions of how we integrate this. Yeah. Some people are absolutely on it. I can't believe it's this point in March and people are so on it. Sidu bidu. We can use the formula book, differentiation results, to find out what it integrates to. Now, this is a standard result. The reason we know this is a standard result is because I want you to memorize what everything differentiates to. I know, for example, sec x differentiates to sec x tan x, and I know, because you've memorized this as well, sec x, cosec x goes to minus cosec x cot x. This is with differentiation. And so if you've memorized these things, then when you try and integrate these things, it's easy because you've already seen them before, okay? Now, if you're not sure about this, in the formula booklet, I know this isn't going to show up at all, but there's a differentiation section, and in that differentiation section that we've got, we should be able to see that cosec differentiates to minus cosec cot, which means that if I was going to integrate this, this is simply going to integrate to minus cosec x, okay? With differentiation, cosec goes to this, so minus cosec would go to that positive thing. And we just have the limits of pi over 6 and pi over 4. And this is why it's a 2-mark question, because it's a standard result. We don't want to make anything too complicated by having a look at this. And then we'll substitute in these things. So personally, I don't know, I know that cosec is to do with sine, because that third letter. I would just work out sine of pi over 4, which I know is 1 over root 2. And I would do the sine of pi over 6, which I know is sine of 30 degrees, which is a half. So this means that cosec of pi over 4 is root 2. And cosec of pi over 6 is just 2. I don't know, I just find something easier about like doing a substitution somewhere else on my page and then coming back to it. So when I sub in pi over 4, I will get a minus root 2. And then from that, I'm going to subtract a minus 2. So it just becomes minus root 2 plus 2. Or more commonly, we would write that as a 2 minus root 2. Let's double check that we have got all of these correct. So this is the alternative way about how this one is being asked, right? This is the alternative way that you could have done this method. So you can always see this in the mark scheme. I preferred my method of having a look at the addition formula with this as well. And we can still see we came up with these correct answers here. And this 2 minus root 2 for this part, okay? I did have an extra question, but it's actually one I'm just going to leave with you to have a think about after this session. I'm going to include this in the I'm going to include it in the PDF. It looks really similar, right? It looks really similar to this question that we did here with implicit differentiation. However, this one doesn't have any implicit differentiation. This one just has a quotient rule for this part that we have, and we have to just think carefully about how to do that one. But I'm not going to do this one in this session because I think about an hour seems about the right amount of time for this. So I will leave you with that to have a think about. And of course, there's a mark scheme to go through this. What I'm going to do now is I'm just going to jump back to my main camera, and I'm going to see if there's anything in the chat that I can answer about that we've got here. So what have we got? And now at this point, if there's any questions you want to ask me, I'm very happy to kind of answer any of these additional questions that we've got here. So yeah, to the slow-mo, send me your question again and I'll answer it. And then Chloe, how do we find questions like these to practice loads? So you'll notice what I've done at the top of each exam question is I've said which paper that it's from. Okay, so if you go to like physics and math tutor, oh, let me just quickly switch back to this so you can see what I'm talking about. So if you go to physics and math tutor, if you go to P3, then that will give you the pure 3. Pure 3 and pure 4 are sort of the equivalent of year 2 maths, whereas P1 and P2 are like AS. Go to physics and math tutor. You won't be able to do the entire paper, okay? There are some parts of this that are in a different specification. However, if you recognize like a trig question, you can do a trig question. If you see an integration question, you can do an integration question. If you see part of it and you're like, wait, what is that even about? Ignore it. It's probably not in the specification that we've got, okay? Right, what else have we got here? What iPad do I have? I think my iPad is just an iPad Air, to be honest. What else have I got here? Can we write CSC instead of cosec? Yes, I'm pretty sure that's going to be expected. I'm not doing a live every day. I need to figure out how often do you want me to do these? And I'm quite happy to do a lot of these. I think they're really nice. I love being able to interact with people on this. I'm going to jump back to the main screen because obviously you want to see me in my nice purple jumper. So I will consider doing these more often. Do my old school miss me? I don't know if my old school misses me. I hope they do. It'd be quite nice if they do. What about, I'm going to do one for stats and mechanics. I definitely would like to do some of these for further maths as well. And Sarara, I'm pleased you enjoyed this session. You had some excellent contributions in here as well. So really, really good. People talking about, will this year's pure paper be like similar in difficulty? It's so impossible to know, but I do think that I will have a better chance to be able to say, after I get the opportunity to see the first pure paper, I do feel like I'll be able to say, okay, feels like we're kind of in the same territory as previous years, or maybe it's going to be like trickier. So we'll have to just wait. I'm afraid we'll just be as prepared as we can be for this. I love, to the slow-mo, I mean, you can see what I'm using here. I've got my iPad where I'm doing all of the writing. I've got my Apple Pencil. It is really, really good, but I use it because I'm now YouTubing. That's like sort of my work, so I think it's good. Pen and paper, you can't beat pen and paper though. And then Ezra, yes, C1 to 4 is good practice. C1 to 4 is the same specification as the ones that we're looking at here. So when I've said P3 or P4, C3 and C4 is good as well, but remember there'll be some topics that you can't do in these things as well. Zatos, after doing all the EdXL papers, which ones do you recommend to do? Madas or Solomon or international papers? So I would be mindful of not just picking one of those things. Madas is great if you're wanting to do some more challenging kind of content, whereas if you want to look at the international papers, they tend to be a bit more kind of like classic. They don't have as much modeling in them, but they do have like a lot of like straight down the line. This is like a parametric integration question. This is a series question. Whereas Madas gets crazy kind of stuff. So you might want to do a balance, because some of that revision is going to be about doing deeper problem solving, and then some of the revision is about getting like faster and like stronger skills with that kind of stuff. So I hope that answers your questions, Atos. I recommend starting the EdXL papers now. I wouldn't save them for anything. I don't think there's any point in like saving these ones that we've got, okay? Whoa, I think I've missed loads of these bits in the chat, okay? So people like them every week. I think weekly would be really good. I'm really pleased people have enjoyed this live. Thank you so much. I love seeing any positive comments, always make me really happy as well. So I will definitely try and do these for stats and mechanics. I will try and do as many of these as I can, definitely in the build up to the exams. What else have we got here? What is the best topic to study every day in pure? Honestly, to Billy English, just do like a different topic every day. Doing a bit different topic every day is going to be good. Oh, someone said they love the chapter summaries. I absolutely love that. Okay, that's so cool. I really have enjoyed making the chapter summaries. Well, I did at the beginning. I got very tired of making them towards the end. That was very tough. I got pretty tired making them. Is there a place to just access the last question, hard questions? No, just like open up the papers and just go to like the last couple of questions that we've got there, okay? I can see that lots of people have said that they have enjoyed this session. If you've enjoyed this session, I've just been planning all of my 8 Easter sessions. I know that they obviously cost money. I put a lot of time into making these things, but it would be for the maths ones, 4 sessions, each one of 3 hours each, plus like an hour plus video for each part and all those questions that come with it. It's a huge amount of content. And I don't know if it's something that your parents might be able to help you out with, or if you're on a bursary and you want to get some help with a discount from me, just send me evidence of that. I would like to be able to have as many people come to those sessions as possible. And they're just really fun. They're kind of like this. They're with like a lot of interaction, probably more interaction because there's a delay when I'm doing these. So when I ask a question, I have to wait a little bit longer to see what people are saying. What else have I got here? People are saying I'm saving their exams. That's so good. In the middle of doing the last question you showed on screen. Oh yeah, which galaxy in the middle of doing the last question you showed? Would you mind showing it on screen for 1 second? Yeah, I'll just leave it here. I think that's probably the part that you were looking at, or maybe you meant the very last question, which might be the one at the end. You can tell me that as well. Okay. I think that's pretty much everything that we've got here. And people saying they like how organized my page is. I put a lot of time into making my channel as good as possible. This is a dream come true. I love that I get to teach maths. First of all, I just loved being a maths teacher. That was such an amazing job to have. And now that I get to do maths teaching we've had like over 100 people in this. It's just been crazy. The fact I now get to do that to people online, and I get to do it, trust me, the live streams and the build up to the exams. I think last year I had like 1,600 people in a live stream. The fact I get to do that as my job is absolutely incredible. So I love doing these things so much. There's no way I can take anyone's exams. I'm not doing any more exams. I've had enough of doing like all of the exams as well. I'm currently not teaching at a school, no. I've dedicated time to like doing a lot of stuff for YouTube, to be honest. Spent a lot of time making all of the further maths videos, and I love it. I love that I get to do this. It's absolutely brilliant. I'll leave this one for the student who wanted this for Galaxy. Okay. Tips for self-taught A-level further maths. Your sixth form don't offer it, but they let you self-teach. Brandon, I would just make sure that you are testing yourself, that you're doing assessments, and that you're kind of keeping a check on like which topics you aren't doing so well on, and hopefully you've got the content finished. You need to get the content finished really by April if you can do. That's what I would be suggesting as well. I really like it when people say, thank you for your time. I'm really grateful that people are happy to have like been in this session with me. So we've got 100 likes exactly. Let's get it to 101. Let's get it to 102. Let's keep going. Okay. Tips for learning proof. You've just got to do more proof. The more proofs you do, the more you'll start to see how they work. Okay. I hope this live stream, you wouldn't have done a live stream with me before, but if you did do a live stream with me before, there's like the camera of me writing. I hope this new setup I've got is kind of a bit cleaner. Oh, sorry, someone wanted it to be on this page. You wanted it to be on this page and I didn't even leave it on the page. I'm so sorry to Galaxy. I didn't even realize that it wasn't even showing, but you can get this in the description as well. Okay, you can get this in the description. When am I? Okay, so I'm not going to be streaming next week because I think I'm going to Turkey. I say I think because today there's been some political unrest in Istanbul. So I just need to make sure that it's like a good time to visit. But I've got my flight booked and everything. I'm planning to make a little bit of video content while I'm there as well of my experiences in Turkey. But at the moment, it's just there's some stuff in the news that's making me think it might not be the best kind of time to go. Okay. So what have we got here? Further maths, I will finish applied content, but I haven't done Copia. Yeah, that sounds good, Sorora. That all sounds good. Okay. I think that's it. Okay, guys. I've really enjoyed this live stream. I've really enjoyed this new setup of using my iPad and of using my my computer to do it in this way. I think it's a lot cleaner for doing this, and it makes it feel a lot more similar to like the Zoom sessions that we do as well. Yeah, arcade grinds. I would say I'd save you some baklava, but there's no way I can save any baklava because I'm just going to be eating all of it. There's no way that I'll be able to keep any. Yeah, I need to stay safe. Yes, thank you, Karan. I will definitely do that. I need to see whether I'm even going or not, because hopefully it's not going to be too sketchy. We will see. Okay, guys. Thank you for coming along to this live. I hope that you've enjoyed it. If you want to come to any more of my sessions and get your Easter holidays really productive, you know what to do, you know where to come for these kind of things. But if not, I'll always see you in my videos, see you on these live streams as well. And maybe next time I'm going to do a speed run. I'm going to have to do a speed run, I think, okay? Ahmed says, don't go, I have a question. Okay, where's your question then? I'm waiting for it. Because if you say, I don't have a question, you've got to delay yourself for 60 seconds. Because I think there's a... I don't know when I'm going to do the rest of the lives. I probably need to make up a bit of a calendar to kind of show where these things are as well. Oh, Galaxy, that's great. Yeah, this is exactly how these kind of Easter sessions work as well. And I put a lot of time into making them, right? I want them to feel like really worthwhile, and I wouldn't run them if they weren't worthwhile. I just wouldn't do that. You can always know that everything I do will always be with your best interests at heart. I want to make sure that you do as brilliantly as you can in these A-levels, okay? Okay, this is the first time I'm doing a live stream from here with some new software, so I think I'm going to figure out how to use it. Any tips about statistics? I don't know, you've got to just go through my chapter summaries and come to my statistics session, because I don't know what else to say for that, okay? If you have integration by parts and it keeps going on forever, there is a special case for that. I cover it in the sessions. I also think there's a video on it as well. Anyway, I better go. Guys, thank you so much for coming to this. I hope it has been a good way to spend your Wednesday evening, and I will plan another one soon, but it won't be next week because I will be in Turkey next week, fingers crossed, okay? Maybe I'll send a couple of pictures. Maybe I'll upload a video when I'm in Turkey as well. My plan is to try and do a video in Turkish soon, but I don't know. That might be a bit tricky. Have a wonderful evening. I'll put these files in the description as well so that you can access them if you want to have a go at them afterwards. See you later, guys. Have a good one. Bye-bye.